them in math. So 127, 128 enclosure. Hey, you can't see you anymore. So, and nobody on the video can see you really because you're too small. For those of you waving at the camera, what? You're like this big in the video. Look the size of man. What? It's you can't see it. The camera's up there, but all it really records is the screen. Okay, so again, there we go. All right, everyone good with homework? I know it's a lot of questions. We're going to try to get to it today in class and do a lot of it together. So your notes, if you would head them to 0.1.1, and I don't know why this is so fuzzy, so my apologies. Not my fault, but I'll still apologize for it. Fraction, decimal, conversion. And from our portions web last chapter, we should be mildly familiar with this, right? It shouldn't be like a brand new topic. What is one of the reasons that we want to convert fractions into decimals? All right? Yeah, to get us to our percent form, because a lot of what we do with mathematics deals with percentages. Right, so if you don't have graph paper out, please do so. I'm kind of trying to waste some time waiting for people to show me that they're ready. I need to change the homework board over there, so my apologies. Again, it was 8 through 17, I believe, and we'll try to get to some of these. 8 through 17. I still need to take a picture of it, so not yet. One thing that I will tell you that some teachers probably would not is you can use a calculator to do this. Now, obviously, if you're a deep thinker like most of us are, you know that you can use a calculator for most of these math things. But it's all, how do I use this calculator to do this most easily? So I've had multiple students come up and say, like, hey, there's no way to type in a fraction on this, right? There is, right? So with these calculators, which was on your supply list, that's this, right? So it's bigger so that you can see it. This button right here that has ND, that's a fraction. It literally puts in a fraction, and the blinking box tells you whether you're typing in the numerator or typing in the denominator. However, while we can do that, I want you to start to get more comfortable with A over B, meaning A divided by B. So real quick, the first thing that we want to write in our notes, and we'll see if this will actually let me write today, how awake it is that the fraction A over B really means A divided by B. And in a calculator, if we want to go do that, A over B, sorry that my A kind of has a long tail, really means A divided by B, which we can, in our calculator, parenthesis A divided by B parenthesis. So that's the other way we can use our calculator to type in fractions. A fraction is just a division problem. Those parentheses aren't really necessary, but they keep things a tad bit cleaner. So, portion A compared to portion B. A lot of times in math, we give you these problems where the answer's not quite clear because you have to do a little bit of stuff. Portion A compared to portion B. Tell me what you notice. Just any, whatever. Actually, take a moment. Draw those on your paper, and especially if you're using graph paper, you should be able to do this relatively easily. Try to make the rectangles the same size. So like when you draw those rectangles on your paper, try to make them the same size as each other. Who can tell me what's different about them? They both have part shaded, part not shaded. Eric?
They're divided differently. While portion A is in thirds, portion B is in fourths.
Ooh, portion A is in thirds and portion B is in fourths. So how can we tell which one's bigger? Like which one has more shaded? What do you think?
You gotta write down the fractions they are, and then you gotta make
common denominators. So this is sometimes easy and sometimes hard because what we have to start here, one of them is easier than the other one. And some of us that have done a lot of fraction work already probably can think of that pretty quickly. Portion A is showing us 2 out of 3, right? Whereas portion B is showing us 3 out of 4. Now, a common denominator will help us, but notice what A asks us to do. Write it as a fraction and as a decimal. Ooh. If we make the denominator out of 100, then making the decimals pretty easy. Now we could make it out of 10. Why don't we choose to make it out of 10 here? All right.
Because it would be very difficult to 4 into 10. Even and you can't even like reduce it to make it 2, like something over 2.
Yeah. Now I don't know if I've said this enough this year. My job, my main goal as a teacher is to make your life easier. Right? Math should make your life easier. I know me giving you homework tonight doesn't immediately make your life easier, but in general, my goal by the end of the year is that you've learned some things that make your life easier. I want you to have that mindset with any math problem you approach. Right, Savannah and Molly? Making sure you guys are with me. So, turning it into 10, not as easy as turning it into 100. How do I do that? What multiplication? Anybody? 25, right? So we do that here, and we get, oh yeah, well, we know that 3/4 is 75 cents, so that becomes 0.75. However, portion A isn't as nice. I'm going to write it in red since it's not as nice. I mean, it's normally some sort of negative. Red in financing terms is bad. So financing, like spreadsheets and stuff, will have 2 different colors. They're red and black. So we'll talk about this as we get towards Black Friday, but the reason Black Friday is called Black Friday is if you have not yet made profit for the year, the goal is that giant day of selling pushes your accounting back into the black, which is positive. Red on a spreadsheet, like accounting spreadsheet, literally means loss, means negative money. But they don't use the negative symbol, they just make it red. So that's why I use red for, like, kind of, bad things or messy things. Molly? Yeah.
Some of the schools in California, like they said it's not allowed to write in red ink on tests because it can signify like bad
Yeah.
and all that.
That makes sense.
And it says that they actually did a study and it increased the stress of the students.
Yeah. I try not to grade in red either. Like, there's a red pen in my set of pens that I buy, and I just normally don't use it for grading. Because I know that, red's a stressful color. But I want this to indicate stressful because this is more stressful than this one. Why? Can anyone tell me why this is more stressful than our other one? Bella? Yeah, it's not simple, so I want to make sure everyone heard what Bella said. Because we don't know an easy multiplication, we have to divide backwards. So we do 100 divided by 3. That gets us the multiplication is 33.333. What do we do when we have, if we want to write it, we put in the Repitin, but if I'm using my calculator, what's the trick here? Making sure we get the right number. Toby? Sometimes that's if it was like a 6, then it would round it up to a 7. So one trick is ignore the last number, right? Especially if the last number is different. Ignore the last number. It's another trick. You leave it in your calculator. So guys, if you want to grab a calculator to practice this, do so. But here's literally what you would type: is 100 divided by 3 gives you that long answer. Then just hit the multiplication button. It grabs that number. And this is why we had you buy these calculators, because they're like formatted to do that. So it'll say A&S, meaning the previous answer, and it will have your multiplication symbol. What do we need to multiply that by? Ooh, careful. 2, because 2's on top, right? So we multiply that by 2, and we get 66.66666. 7 isn't real. The last number is a lie. So this becomes 66.6 repeating, which we can then write as 66.6 repetend percent if we wanted. Or if we just wanted decimal, right, 0.66 forever.
Mallory Ton, please come to the office. Mallory Ton, please come to the office. Thank you.
Please make sure you have those representations written down. The circumference divided by the diameter. If you have a perfect circle, if you take the circumference divided by the diameter, that's how you get pi. It's always going to be 3.14. Is that division? Distance around a circle divided by the distance across it comes out to be 3.14. No matter what. If it's a perfect circle. Are we all good here? Because I'm going to clear the whole screen. All right. So then we start to look at these really interesting situations where we can predict if it's going to repeat or terminate based off the division that we see, and more so the denominator, right? Those denominators tell us very specific things. So let's say I have 13 cheese sticks, right? Who doesn't like a good, like the peel apart, whatever cheese sticks? So we have 13 cheese sticks and there's 5 of us, right? So we want to figure out how much will each of us get. So first off, will each of us get 1?
No. Yeah.
Yeah, we'll at least get 1. Now, Zach, what? You said how do you know we at least get 2? 2 times 5 is 10. Yeah, 2 times 5 is 10. And then we got to start cutting up the cheese sticks, right? So now that we only have 3 cheese sticks left and there's still 5 of us, what could we do to start to divvy up these cheese sticks? Yeah, literally cut them, right? So if I cut them apart in halves, because I heard a couple people say, well, cut them into halves. Well, we could cut into halves, but then we'll give away 5 halves and have 1 half left over. So we could also, if we want to do this mathematically, and for any fans of long division, what would we do next over here in the long division, Araya?
Okay, so you have to add another 0 at the end. Well, first you have to add a decimal at the end of the
Yeah.
and then put a 0 at the end of 13, bring down the 0, and then you just find the multiple 5 times 11.
Yeah. So give me your eyes up here. Exactly what Araya said. We have to put the decimal, then we drop a 0. But what that's actually doing is saying instead of having 3 cheese sticks, I've now made 30 portions of cheese sticks, but each of those portions is how big? A tenth, right? So instead of cutting them in half, because we're working with decimals now, we want to cut them into tenths because we can talk in tenths. So what long division is actually doing, guys, is splitting up your pieces into more pieces so we can work more easily with them. So each person then ends up with 6 tenths on top of their 2 cheese sticks they started with. And we get 2.6. So is that repeating or terminating? Terminating. It stops, right? If it stops, it is terminating.
Why do these people care so much about
why don't we just have 2 and save them?
She's delicious.
Because we want to be fair. We want to be fair. All right, you ready for me to blow your mind?
Yeah.
It's too early in the morning.
It's not too early in the morning. I don't know how long you've been awake, but maybe you should get up earlier.
I don't have an alarm.
So we've investigated 1/3 before. Yeah, I probably would. 1/3 is 0.3 repeating. 2/3 is 0.6 repeating. But is there a rule or a trick or something that we could do to figure out why? Why do we get these things and how can we remember them? I want you and your partner, because you don't need 2 calculators, grab at least a calculator and do these divisions working through the ninths. As you get these answers as decimals, please write them down on your paper. Bless you. it down. You're looking for a pattern. Yeah, but I have it down there because I don't really want you guys thinking about it yet. We're going to not type that in the calculator. We're going to talk about it. All right, so a few people I've heard saying it. 1/9, you're getting 0.111111. Molly, what do you get with 2/9? Just type in the division right now. 2 divided by 9. And then hit enter. What do we get?
You get 0.22.
Eric, what about 3/9?
Can I assume that it's going to be 3 repeating?
How are you, now let's not call that an assumption. How are you making that inference?
Because it's basically the equivalent of the numerator, and it's just repeating for infinity.
So Eric's saying, I recognize the numerator value is the number repeating. Right? Also, Eric's a really smart guy, and he probably just figured we all saw this, but 3/9 is a third, right? It reduces. So we already knew what 3/9 was before even doing it. So then, Luz, what do you think about 4/9? Ooh, 4 repeating without using calculators. Let's make predictions. What do you think about 5/9?
0.5 repeating.
0.5 repeat. 6/9? 0.6 repeating. 7/9? Yeah, and you can check these in your calculator. 0.8 repeating. So, no, wait.
1.
But guys, we had a pattern. Right? We said we saw a pattern. Wouldn't this be
It would.
0.9 repeating?
It's not.
So I'm going to put a question mark in here. So here's a mathematical argument that has been going on for a long time. And I have some students in my afternoon, like my Math 8 class. You could probably guess who they are from being with them in other classes, but they get very upset when I try to argue math with them. And sometimes there's not a right answer, and that can be really upsetting for people too. So there's this old question. And I want you to write it down on your paper. And we're not going to try to come to an answer today, but we're just going to discuss it a tiny bit. Does 0.9 repeating forever equal 1? And we're not going to get into a big fight about this today because I want us to get to your homework. Bless you. But the question that most mathematicians will ask you if you say no is, okay, if they're not equal, what number's between them? So if we say that these are not equal, right, and this is where like mastery learning is different from just like memorize these things. I'm not trying to tell you yes or no, right or wrong. I'm just trying to get your brain to like process an idea. Has Mr. Estes done thought experiments with you before?
No.
Okay, so a thought experiment is like, we understand the reality we live in. We all know like the assumed facts and things like that. But in a thought experiment, you just like step outside of our current reality and just say like, okay, come over here and just be in this thought space with me, right? So let's say there's a thought experiment like where 1 + 1 does not equal 2, right? That would be like a thought experiment preface of like, if we now live in a world where 1 + 1 does not equal 2. So as we go through the year, we're going to do some like thought experiment type things. What I want you to grapple with a little bit on your own is like, if these are equal or aren't equal, what else would that mean? Right? And what does it mean for something to repeat forever? Right? Like, what's the biggest decimal place? Or maybe not biggest, maybe smallest is what I guess I'm trying to say. What's the furthest out there decimal place? Yeah, there isn't one. Right? There is no end. There's no smallest value. So if this goes on forever, how far away from 1 is it? So just an interesting thought for us here as we recognize these patterns. All right, you ready to get your mind really blown? We're going to do this same thing, but with the sevens. Okay, so you can use your calculator. 1 7th, 2 7ths. Like we're doing the same thing. I will offer up a prize to anyone who recognizes the pattern and without using your calculator can fit. So you can use your calculator for the first 3. But then I'm going to offer up a prize to anybody who can discover the pattern and without their calculator tell me 4 7ths, 5 7ths, or 6 7ths.
107.
And what's interesting here is without a calculator, I can tell you what these are.
And you just know it by your head and not by previous causes.
Oh no, I don't just know it because of my head, but it's so beautiful. Huh, yeah, the Rakuten goes over that whole thing. When you type that into your calc, now remember, ignore the last number. Remember, ignore the last number that shows up on your screen. You get 0.14285714285714285. It will keep going forever, like that, in that pattern. Those 6 numbers repeat themselves. Without me using a calculator, right? I'm going to take your prediction. So, Morgan, if you think you know it, just hang on to it for a second. This is 285714. All repeating.
And we need to find out.
Guys, these sort of things is why I fell in love with math. I'm like, oh my gosh, what is going on here? 3 7ths. This is the last one you can use a calculator on. This is the last one you can use a calculator on. 4 2 8 5 7 1. All repeating. Now, I'm not some sort of like super intelligent, like I'm not any smarter than you guys. Like really, I'm not any smarter than you guys. I just have more experience. Morgan, you had a hand up. Do you think you can tell me without your calculator what 4 7ths, 5 7ths, and 6 7ths will be? Not yet. You think you know the pattern? Okay, hang on to it for a second then. Nick?
For 4 and 5 answer.
Yeah, do you know what 4 7ths is? If you get 4 right, then you can move on to 5 and 6. But you gotta get 4 right first.
It's 8, 4.
Nope. Sorry. I know when it starts.
Oh, it's.
Toby?
I want to say it's like 0.
It's not 0.8. That's barely over a half, guys. Right? 4 out of 7 is barely over a half.
Does it start with 0.6?
It's not. There's no 6 in any of these. No. If I tell you it starts with this.
Hold on.
Bella?
Now, hold on just a second.
Did you type this one in? Oh, no, then no. Callie?
0.57142.
Close.
Well, that was.
You're missing the 8. Now give me your eyes for a second. Put your pencils down. We're going to have to go get a mop or something because I'm going to have brains all over the floor. What's 7 times 2?
14.
Double that number. Double that number. 56, right? So it doesn't work out perfect. What we have is 14, 28, 50. Well, we're close to 6, but 57, right? Multiples of 7. Now, 57 is not, but 56 will be.
So it's what is the number?
Check it. 1, 4, 2, 8, 5, 7 is the order the numbers stay in. But we've already started with the smallest number of 1. What's the next smallest number? The 2. So we start with the 2. 2, 8, 5, 7, 1, 4. Same order of digits. We just started with the next one. What's the next biggest number in that set after the 2? The 4, right? So 3 7ths starts with the next biggest number, keeps the same order, 4, 28, 57, 1, because we broke apart the 14. What's the next biggest number? The 5. So same order, 5, 7, 1, 4, 2, 8. So here, I want everybody to try to make your prediction with what is 5 sevenths going to be. So the pattern we just recognized was the digits stay in the same order. What would the next biggest digit be? Toby?
71428.
Yeah, the 7. Right, so 7, 1, 4, 2, 8, 5. All of that repeats. All of those 6 digits repeat. So down here, what's the only digit we haven't started with? 8. So 0.8. How cool is that?
That's cool.
All right, now the last one. This one's a little bit easier to discover. Oh, that's 2. 11ths. 11 is now your denominator. We're using your calculators to start. Use them for the first like 3 or 4, but then see if you can make a prediction.
Hey, wait a minute. Hey, wait a minute.
Cash money. You on what?
1/11 gives us 0.09090909. Molly? 0.18, 18, 18. 3 11ths. You can keep going if you think you.
3 11ths is 0.2727.
So what do you think 4 11ths is going to be? Nikki?
It's 0.363636.
9, 18, 27. How did you figure out 36?
Because they're all multiples of 9.
They're all multiples of 9. So this is 36, 36 forever. 5 11ths.
Is gonna be 45.
What is 5 times 9?
45.
Cash money.
You want to know why this happens?
Why?
Cash money.
I'll do it with 6 11ths.
Is that one?
What should I multiply 11 by to get as close to 100 as possible? 9.
Hey, wait a minute.
So when we do the same thing in the numerator, we get, well, 6 times 9 is, okay, 54, but it's 54 99ths. That division, if you set up, and if you want to be like mean to little brother or little sister or something that's just learning how to long divide, be like, hey, I'm going to help you with your homework. Let's try this problem. This problem will never end. You know that song that never ends, and it goes on and on, my friend. Okay, this, same thing. These repetitions that we're getting out in our decimal conversion is because the long division will literally never end. That's what creates repeating decimals. Okay, so I just want to show you guys some of those really cool, beautiful, like relationships between fractions and their decimal counterparts. We're going to skip past that, because that's another good example of everything we just did. And let's spend the last 10 minutes working on your homework, because I had committed that. Now, there is one tiny typo, because I did not get these back from the copy center in time. Your header accidentally says CC3. It's not. It's CC2. So if you want to cross out that 3 in the header, it is CC2 work.
Can I get
Thank you.
Why, thank you. Hey, I gave you guys 3. As long as Toby shares. But if Toby doesn't share, I guess that's a problem. 2 for me. Toby, do you want to do it twice?
I think Toby would love that.
I want real quick for us to. First, I'm going to change this header. If we come to the back over here, guys, this question should relate exactly to what we just talked about. Can I turn my value into a fraction with a 10 or 100 or something like that on the bottom, or not? If not, it doesn't work out as well. So remember, it could be 10, 100,000, 10,000, 100,000, whatever you want on the bottom as multiples of 10. So I think I missed a space here. Really what I want us to look at is 216, because here's where I have an issue with teaching multiple math classes. I'm trying to remember if we've done much with the, I call them magic diamonds here. Have you guys seen these before, the diamond problems? Okay, so let's take a moment together to make sure that we all understand what's going on. Compare, just like we were just doing with those fractions, compare the numbers that you see with each other and how they could relate. Can anyone explain to us the relationship we see with these diamond problems? Is that a hand? I can't quite tell. No? Nick?
The 2 numbers on the side, they're multiplied and added together to make an example. 2 and 7.
Well, use one of these. Explain how these work.
For like the first one, 5,
Yeah.
2, 10, 7. 5 plus 2. If they're added, they make 7. We go to the bottom. And then 5 times 2. If they're multiplied, then it makes 10.
Oh, does everyone see that? Hold up, so like look at like the third one, because sometimes it's easier when like I pick out one that's like that has the biggest numbers, right? So I'm gonna look at that because it looks kind of special. It's got really big numbers. How do 8 and 7 relate with 15 or 56? Right, Toby?
Yes.
Yeah. No, I wasn't even. There was nothing to agree with. Pay attention. So when we look at this and we start to say like what is the relationship? 15 is the sum. Right, when I add the numbers on the sides, I get the bottom number. But 56 is the product. Right, so if you want to go ahead and complete this problem, we can do it together. What should go down here when I look at 3 and 4 pairing up together?
7.
Ooh, 7 on the bottom because that's the sum, but 12 goes on top. Right, so 12 would go on top, 7 would go on bottom there. Now, if I jump, I'm going to jump B, so I'm going to have you guys do that on your own. If I come over to like C, now they've changed things up on us. Now they gave us, what's the top? Is that the sum or the product? It's the product, and then they gave us one of the pieces. So what should the other piece be to make 12? 6, right? So then what does my bottom number become? 8, because that's the sum. D is going to be the hardest one. What 2 numbers add up to 11 and multiply up to 28? As we start this process, we'll mainly be using all whole numbers. So try whole numbers first. Do you have a thought? 7 and 4, 7, 14, 21, 28. Yeah, 7 and 4 make 28. And if I add 7 and 4, yeah, so 7 and 4, there we go. On 17, sorry, I was trying to squeeze these onto one piece of paper. They're just asking us to make an improper fraction. So if we want to review how to make an improper fraction, my style that I like to talk about is the triangle. Not only are triangles just nice, but it's an easy representation. So I'm trying to get somewhere where I have more space to write. What I mean by the triangle, if I have, let's jump to B at least, 3 and 2/5. Here's my triangle. I grab this, I go here, and I come up. So what I mean by that, who wants to talk this out? Yeah.
So you do
Yeah. Yeah, we have 3 entire like pizzas or whatever you want to think. So what do I have then? 3 times 5. 15. And then come up to do what?
You have to add the 2.
So we will get 17 fifths. All right, grab your whole, take it to the denominator, then bring it up.
So then, like, going downhill, what's happening?
So then 2 and 4 fifteenths. And like I said, guys, you have a longer homework, so I wanted to do some of it together. Grab the 2, come down through the 15, and then go up. So 2 times 15, 30. Right, add the 4, 34 over 15. Any questions on that? So we still got about a good 5 minutes. We've done a couple of these together. If any of them look a little difficult, I'm happy to keep doing stuff up here. But aside from that, you guys just use this time to work. And then we'll chill here even once everyone else starts moving. So we're going to go through the wall into the gold room. So like, guys, when we get time to do homework at the end of class, please use it. Like, I really don't like throwing you guys under the bus when a parent reaches out and is like, my kid's days behind in homework. What's going on? They never have time. I'm like, well, they were farting around in class when we gave them time to work on it. And that's normally what happens. Seriously. Parents contact us. They're complaining that you guys aren't done with homework. I'm like, well, we gave them time.